The broadcast is now starting. All attendees are in listen-only mode.
Good day, everybody. We will start the broadcast in less than 1 minute. Good day, everybody. My name is Mark Demisho, and I'm the webinar administrator for IADLIS, the International Association of Directors of Law Enforcement Standards and Training. And I'd like to welcome you to our second webinar series in the IADLIS DDACTS training series. This is the first of that second webinars, this one on GIS mapping and hotspot identification. The webinar series is made possible by a grant from TxDOT, the Texas Department of Transportation. And the intent of these is to continue efforts to raise awareness in the law enforcement community of the need to find ways to reduce not just crimes, but also crash rates, since the rates of crashes far outpaces that of crime. This training is part of TxDOT's effort for a statewide implementation of the nationally recognized DDACTS, data-driven approaches to crime and traffic safety within the state. And is presented by IADLIS, the International Association of Directors of Law Enforcement Standards and Training. You can learn more about us at www.iadlis.org. Now, folks, this is a hands-on webinar. You should each be at your own workstation, not multiple users at one workstation. This will become very important later if you have just registered and you have a whole bunch of people clustered around one screen. When you go to take the test, you won't be able to. They'll only allow you to take the test if you have registered and have your own screen. So make sure you're at your own workstation. It also helps if you have two screens, one for the webinar broadcast itself and one for the ArcGIS information that we ask you to download ahead of time. If not available, at least try to find the biggest screen you can or split your screens so you can see both the presentation and the ArcGIS information. A little bit of housekeeping here. Your microphone will be muted, and if you want to ask a question, please go over to the toolbar on the side and use that raise your hand feature that you see right there, and that will alert me that you have a question, and I will either try to answer it myself or I'll pass it on to Christopher through the chat system, and Christopher will raise it. If not, I'll at the opportune time I'll interject to make sure your question gets answered. You can also type it in the chat box of the GoToMeeting toolbar, and that will also alert me, so you can also see that I'm paying attention to you and that your question will get answered. Looks like we have 47 people on board here today, and so sometimes if there's a lot of questions at one time, it takes me a few minutes to get back to all of them, so just be a little patient. But if nothing happens and I don't respond back to you, you can always give me a call on the old-fashioned way on my phone at area code 316-640-6513. That's 316-640-6513. You can download a copy of the handouts by clicking on the handouts icon over on the toolbar also. These are the two that I asked you to download ahead of time, but if you didn't, they're on the handouts file. You can download them now. One's called Intro to ArcGIS Handout, and the other one's called Crime and Traffic Analysis TX. Now, you'll receive the test instructions at the end of the webinar, how to take the test and how to receive your course certificate. It works a little bit different than it does for the crime analysis webinars if you've been going in on any of those, but it is the very same way that you have been doing for the previous Access series through the TxDOT DDACTS webinar. At this point, it's my pleasure to introduce Christopher Bruce. He is the IADLIS DDACTS Analytical Director. Christopher was a crime analyst for 17 years in the Danvers, Massachusetts Police Department, and then later with the Cambridge, Massachusetts Police Department. Throughout his career, he's been extremely active in the crime analysis community. As president of the International Association of Crime Analysts, he's served 2 terms of vice president of the IACA, and currently he is the vice president for membership. He's also previously been the president of the Massachusetts Association of Crime Analysts. He frequently provides conference presentations on crime analysis and week-long training classes on topics such as crime mapping, spatial statistics, and the Microsoft Office applications. Now, since 2011, he's been the analytical director for the IATLS NHTSA DDACTS project, and since 2014 he's also been the program manager for the ILS BJA crime analysis project, and in both cases he provides workshops, training, and technical assistance across the country. He also works in a variety of other contracts for governmental and nonprofit programs, including currently with the Massachusetts Gaming Commission, and he's taught graduate and undergraduate classes at Tiffin University and Western Oregon University. When he's not on the road, he enjoys the view of the harbor from his home in Stockton Springs, Maine, and that's where he joins us today. So with that, I will go ahead and send the presentation over to you, Christopher, and you should be able to take it over.
Very good. Thank you very much, Mark. Well, hello, everybody. Thank you for joining us on this webinar, and particular welcome to those of you from Texas. We're here to talk about ArcGIS, the most popular GIS software in use in law enforcement, and its uses for DDACTS specifically. And to give a little historical perspective, since really the dawn of modern law enforcement in general, police have understood the contributions of geography to safety, and therefore to the importance of allocating police resources based on this geography. And I've got this quote here from August Vollmer, who is often considered the father of American policing. And 100 years ago, over 100 years ago, he talked in this quote about the importance of identifying and analyzing crime hotspots, although the term hotspot itself didn't exist at the time. And undoubtedly, he would have said the same thing about traffic collisions, but of course, this being 1911, there really weren't any hotspots of traffic collisions quite yet. The automobile was still fairly new. But he's talking in this about the importance of basically predicting where crime is going to happen by geography. And so, that's what we did for decades, basically. Over the next 80 years, police administrators and then full-time crime analysts would figure out such hotspots with colored dots or push pins stuck in paper maps. I got started doing this kind of thing in my career in the early 1990s at the Cambridge Police Department. And it took 3 weeks sometimes, to map 500 crimes or 500 traffic collisions on a map. But this basic process didn't change until the desktop computing revolution brought computer mapping programs to the world's police agencies in the 1990s. And for those of us who were in the field at the time, it's hard to overestimate the impact of computer mapping or geographic information systems on crash analysis and crime analysis. First of all, there's the speed. The pin mapping that took several days with push pins or colored dots could be accomplished in minutes through a process called geocoding. And more important, since every dot on the map in a GIS represents an underlying record in a database, it was now possible to select and filter records by factors like crash or crime type or time of day or day of the week or the severity, something that would have involved many frustrating hours of pulling pins out of maps and putting them back in the old days. Perhaps most important, GIS allows us for the quick identification of clusters of activity, of hotspots, something that's hard when looking at thousands of dots or pins. This map that you're seeing in front of you, this comes from the Alexandria, Virginia Police Department in the 1970s, and he doesn't have enough dots on there that you can't just simply look at and identify where the clusters are. But if he'd mapped several years worth, it would have just been a map full of pins, and there would be no way to draw your eye to the places that really need the attention, and that's what hotspot analysis really does for us. And so, of course, in the modern era, we use techniques like this to cluster those pins and to help identify places that need that extra police attention. Any agency that's serious about identifying, analyzing, predicting, policing, and evaluating its hotspots needs a proper geographic information system and the analytical skill to use it. And so this webinar series is going to provide a ground-up approach to the concepts and the use of GIS in one of the 21st century's most important policing models, DDACTS. Today, we're going to talk about what a GIS is and the basics of how to make use of ArcGIS. We're not going to start mapping our crime and crashes yet. It's a little bit too soon for that, for those of you who are just getting into this. So you need to get the terminology, and you need to learn how to create a base map in ArcGIS in order to accommodate the later mapping of crashes and crimes. Next webinar, we'll talk about actually getting the dots on the map from your records management system or wherever you manage your data. And in the one after that, we'll talk about the various ways to take those dots and to turn them into proper hotspots so that we can then determine our DDACTS target zones. But here we have a lot of foundational material. Now, to clarify some things that Mark said during the introduction, I don't really encourage anybody listening to this to try to replicate the lessons that I'm going to be doing here at the time that I'm doing them. We're just going to be going a little bit too fast for you to effectively do that. However, you will, after the webinar, have access to a recording of it. And what I would encourage you to do is rewatch it a couple of times, and especially rewatch it when you have your own GIS program and your own GIS data in front of you, and then you'll be able to pause it as necessary and follow along with me as you create a base map for your own jurisdiction. Today we're going to talk about the uses of GIS for DDACTS specifically. We're going to get a little refresher on what DDACTS is and what GIS is. We're going to talk about the differences between GIS and some online mapping applications that do quasi-GIS tasks, but aren't really full GISs. We're going to talk about ArcGIS, the ArcGIS suite and the different applications that it involves. We're going to load some data into an ArcGIS map, and you'll see all the different data sources that ArcGIS recognizes. We'll move around, we'll navigate, we'll zoom, we'll symbolize, we'll show you how to navigate basically an ArcGIS map, and then we'll turn that into what's called a base map, a map that you save that you can then do all of your other mapping on top of, and then you don't have to do any of this stuff again once you've got that saved. And finally, during the course of this, we're going to talk about the importance of coordinate systems and projections and how they affect your ability to effectively map crime and crashes. For those of you who have not attended a DDACTS workshop or for just needing a refresher, DDACTS is an operational paradigm that uses the analysis of location-based crime, traffic, and enforcement data to support effective and efficient deployment of resources. It's hotspot policing, basically, but with the important addition of traffic collisions, because many agencies, as Mark talked about during the introduction, are neglecting their traffic crashes when it comes to making decisions about where they should do effective policing. And so we try to do in DDACTS is to synthesize the analysis of traffic crashes and crimes so that we can create a deployment plan that addresses both at the same time, synergizes our resources, and has a positive effect, of course, on safety in our communities. DDACTS depends on 7 guiding principles. First of all, we try to focus on outcomes. So we have agencies set very specific goals for what they're trying to achieve in their hotspot policing models. We encourage the enlistment of partners and stakeholders in the DDACTS program. It's a very community policing oriented philosophy. It's not something that we do in conflict with the community, but something that we do in concert with them, focusing on their outcome, on their goals and priorities as well. Certainly, everybody who's worked in policing knows that everybody in the community pretty much wants more enforcement of traffic speed and other issues on the streets near their houses. And so we try to work with them to prioritize that and to let them know that we're doing. There's a huge data component, of course, to DDACTS. We have to collect data on crime and traffic crashes and enforcement and other issues from our CAD systems, our records management systems, and our other databases, and represent them on the map so that we can see where to deploy and when to deploy. And of course, for crime analysts, and that's what we, of course, are historically called, crime analysts, even though we often analyze traffic collisions as well. There's an intensive analytical component to DDACTS. Right? It's more about than just representing our data as hotspots. We have to drill down into those hotspots and identify what types of crime and crashes and what time of day and the day of the week and the types of modus operandi and causal factors that are at work in areas, what types of people are involved, what types of vehicles are involved. That way that police know more than just to go to a particular place. They know what type of activity to look for when they're there, and what types of activity to enforce. And then it's about tying the appropriate strategic operations to that analysis, so that we do targeted tactics and strategies based on what the analysis shows us of our crime and traffic crash hotspots. One of the guiding principles is about information sharing and outreach, getting information back out to the community about what we're doing and what type of results that we're having. And then finally, monitoring, evaluating, and adjusting our DDACTS strategies based on our experiences in the initial deployments. Now, there is a place for analysis and therefore a place for GIS in all of these 7 guiding principles. We won't have time to focus on all of these over the course of this 3-part webinar series, but GIS potentially has a role in each of the DDACTS guiding principles in terms of helping identify which outcomes we want to achieve in the first place based on where hotspots are and how they're growing or not growing over time. Obviously, there's a huge GIS component in data collection and data analysis, because the GIS is the primary tool that we use in order to represent our data geographically and to analyze it. We can use GIS to help identify where we're going to deploy our resources, where officers are going to set up to do enforcement, and of course to share the results of that analysis and those decisions with the agency and with the community. And the GIS is vital to help us evaluate what's happening in our hotspots. We have to use GIS in order to identify the crimes and crashes that occur specifically in our target zones, so that we can compare to the past, to the present, and the future in those target zones. So there's a place at all times for GIS in the DDACTS process. What is GIS? I've been using that initialism. What does it stand for? It stands for Geographic Information Systems, and it describes hardware, software, and procedures designed to collect, store, retrieve, manipulate, analyze, and display spatial data. It is computer mapping, but with a strong database component to it, as we're going to see. Every feature on the map has an underlying record in a database that allows us to do much more with the information than to simply visualize it the way that traditional maps do. And because of that, it's important that everybody understands that Google and Bing and a lot of the other online sources, even Google Earth, the application, aren't really GIS applications. They allow us to do some types of mapping, but they don't allow us the full range of techniques and products that we want to achieve with a proper GIS. Now, I should clarify, Google Maps is what they have available at Google is in fact a GIS. I mean, they can do all kinds of neat stuff with the maps and then serve the results to their clients, to their customers. It's just that you can't do those things, right? So when we see a map on Google, it is the product of a GIS, but we can't separate, for instance, the different data layers that we're seeing to make streets a separate layer from the businesses or the buildings or so forth that appear on top of the streets. We can't do things like buffer the intersections and identify all of the incidents that occur within those intersections. We can represent 6 points like in a tactical map like the one that's on the screen here, but we can't upload thousands of records and geocode them. We can't choose what appears again on the map in terms of the data layers. We can't select by geography, or we can't even in many cases select by attributes of the data, like to show us just burglaries or just burglaries that happen on a particular shift or something like that. And although they do sometimes have some hotspot techniques, they don't have the full range of hotspot techniques that a proper GIS gives us. If you're going to do any serious analysis for your police agency, there's no getting around this. You need an actual GIS system. I work with a lot of agencies that really try to implement half measures because they don't want to pay the price to actually purchase a GIS, and it never really quite works. You never get the full functionality of a GIS when you try to use online tools, when you try to use Google Earth, when you try to use Microsoft Streets and Trips, whatever the other half measures that you think might work, it doesn't really. You're going to hit a wall at some point, and if you're going to do serious analysis for your agency, you want to get started using a GIS right now. For smaller agencies that don't have full-time analysts and don't have much need to use GIS, other than to create some basic hotspot maps for DDACTS purposes, that's where your partners come into play, identifying key partners that actually are GIS professionals. And you almost certainly have one, as we'll talk about, in your city or county. Now, there are a number of different GIS applications out there commercially. There's MapInfo, there's ArcGIS, there's a free one called QGIS, but ArcGIS, made by the ESRI, which used to stand for Environmental Systems Research Institute, but now I don't think it stands for anything in particular. They make the software that is used by, I would conservatively estimate, about 85% of law enforcement agencies across the country. And because of that, there's just so much more training and technical assistance available for ArcGIS than there is for any other application. It makes sense. This is an area in which it makes sense to go with what everybody else does, because when you need some help, your analyst next door will be able to talk the same language that you do because they're using the same application. And technical assistance providers like me are more versed in ArcGIS probably than any other GIS application. It's also almost certainly the GIS application that your city or county GIS department uses, and therefore they're going to have the data and they're going to have the expertise in this software. So again, this is one area it makes sense to go with what everybody else does. There used to be multiple versions of ArcGIS called things like ArcView, ArcEdit, or ArcInfo, but they've consolidated those into these 3 license levels now: basic, standard, and advanced. And for what crime analysts and anybody analyzing crime and traffic data at the local level, for what you need, almost certainly the basic license is enough. The advanced licenses are for GIS professionals who are going to be creating the data, who are going to be editing the maps, and that's not you. You're going to be using them in order to represent your crime and crashes. The basic level is almost certainly enough. Now, ArcGIS itself is not an application. You will never find on your computer an executable called ArcGIS. Instead, it's a suite of applications that comes with the ArcGIS installation. And the 2 most important, and the ones that we're going to focus on for the purposes of this workshop, are called ArcMap and ArcCatalog. And ArcMap is the application in which the actual mapping is done, and you see it on your screen right now. It has the various data layers that you want to represent, and you can move around the map, you can identify features, you can label things, and you can represent your crime and crash data on the map. Most of your work is going to be here in this application called ArcMap. The other important application, though, and this will become particularly important next month when we have our second webinar, is called ArcCatalog. ArcCatalog is the application that you use to manage the data that you use in ArcMap. It allows us to do things like rename and move and change the projection of different source data, and it allows us to establish connections to databases where we might get our crime and crash data. Again, lots more about that next month, but ArcCatalog is an important application, and we have to learn a few features in it. Fortunately, in ArcMap, there's this catalog window that has some of the same features of the ArcCatalog application. So a lot of times you never have to leave the ArcMap application if you can make use of this catalog window. Now, last year rather, ArcGIS announced that in the future it's going to be ultimately switching its resources to a new application called ArcGIS Pro or ArcGIS Professional, and they've been bundling that application with all new licenses of ArcGIS for desktop. So if you've bought, 10 point, I can't remember exactly when it started, but 10.2, I think maybe, or 10.3 and above, you'll probably have ArcGIS Pro along with the ArcGIS for Desktop license. ArcGIS for Desktop isn't going to go away very soon, but eventually they'll be encouraging people to transition to this new application. And so we're going to have to learn all this stuff over again in the coming years. But right now, again, most of the expertise, the training, the technical assistance, and support is for the existing version, ArcGIS for Desktop, and so that's what we're focusing on here in this webinar. Okay, to understand how ArcMap works, you first have to understand the data that goes onto the map. And there are three types of data that we can put onto our map: points, lines, and polygons. Right. Points are literally they have no dimension. They're just, I'm sorry, they just have one dimension, a latitude and a longitude, and they're good for mapping things like street lights and bus stops and crimes and traffic collisions. Lines have two dimensions, and they're good for mapping things like streets and rivers. And polygons have three dimensions, and they're good for mapping things like police beats and neighborhoods and city boundaries. Every layer or every source data in ArcGIS has to be one of these things. You can't mix and match on the same layer, but you can mix and match the different layers together to make a map. And so you take the different points, lines, and polygons, and you put them together. You overlay them on top of each other, and your result is a final map. Okay. So, for instance, in ArcMap here that you see on the screen, I've got this is the city of Allen, Texas. And what we're seeing here is the city boundary of Allen, which is a polygon, and the water, the lakes, and so forth throughout Allen, which is also a polygon. And then we've got the roads for both Allen and Collin County that surrounds the city of Allen, and both of those are lines. And then I can go over here and add, there's a points layer that has churches and schools and a few other key points, and that's clearly a point. And notice that in the table of contents here that they're drawn in a particular order. ArcGIS is pretty smart when you add data to the map about how to draw it, because it knows that if it puts the points underneath the city boundary, for instance, then the city boundary is going to overwhelm the points and the streets and everything else, the lakes, and you can't see anything. So the order is actually really important. Think of it like putting Mylar overlays on top of each other and then projecting them onto a projector. You don't want to put the most opaque one on the top, because that's all you'll see. So you want to stack smaller features smaller features on top of larger features, and then generally you're going to put lines on top of polygons and points on top of lines. Okay. Now, as I add data to this map, one of the things I have to be particularly cognizant of is the projection or coordinate system, and coordinate system that the data uses. ArcGIS figures it out for us, and it arbitrates different coordinate systems and different projections to create a composite map. But sometimes we're adding data and ArcGIS doesn't know what coordinate system it's in. We have to tell it, and then that becomes vital in determining where our dots or our other physical features appear. So everybody who's going to use a GIS needs to know a little bit about why coordinate systems and projections are important. The reason that we project data, we project maps, is because the Earth is a curved surface. It's a globe, and a map is by nature a flat surface. And so we have to choose the right what's called the projection to minimize the amount of distortion and in shape or size or distances between features that happens when we take a curved surface like an orange peel, half an orange peel, and we smash it down into a flat surface, which inevitably is going to cause something to stretch or distort or rip in the case of an orange, and create something that isn't quite perfect, that it doesn't perfectly represent the underlying geography. Now, that's not a huge deal for a single city or even a single county or even a state, really, unless you're really doing some very finite mapping, like you're doing surveying or something. For most of what crime analysts need, it doesn't really matter which projection we choose, as long as the basic result represents something that looks like our city, and we can use it to deploy resources. We're not mapping global data here, so the fact that for instance, in a cylindrical projection, the fact that Greenland looks about as big as Africa, even though it's less than a 16th of the size of Africa, doesn't really matter for our purposes, because we're not mapping crime on a global basis. Here's a cylindrical projection, a conical projection that tries to minimize distortion for continents in the northern hemisphere. But again, we're not mapping an entire continent at once, so the distortion that we're going to see is somewhat minimal. Depending on the projection we choose, we might see some differences in the positioning, orientation, and shape of even a small city. And if you change from one to the other, it might look jarring immediately, but over time, any projection you choose is something you'll get used to, and it will look fine. Even though, if, for instance, as you see here on the screen, at the national level, different projections can result in a fairly different looking geography for the United States. Why projection is important isn't so much the way the map looks. It's important because different data sources will come in different projections, and we're going to have to merge them all. We're going to have to synthesize them all onto a map. Now, every projection comes with its own coordinate system. And the way a coordinate system works generally is that it picks a point somewhere to the south and the west of the well, that's not true. It picks an origin point somewhere on the map, and then it measures every other point on the map in terms of its distance on the x-axis, or the horizontal axis, the east-west axis, from the origin point, and then it measures the y-axis, the vertical distance, or the north to south distance, from the origin point. And there are a variety of different coordinate systems based on the projection that's being used, but the two most common, the ones that you'll almost always encounter in your crime and crash data, are just plain old longitude and latitude, which has its origin point at basically somewhere off the west coast of Africa on the prime meridian and then the equator, and the U.S. state plane coordinate system, which has different origin points depending on the state or even the zone within the state. For instance, Texas, I think, has 5 different zones. All right. So the way you'll know what type of coordinate system you have is largely by the way the numbers look. So if your records management system exports data and the numbers are all positive and they're in the hundreds of thousands, clearly it isn't longitude and latitude, because longitude, every longitude in the Western Hemisphere where we live is negative to start with, and it never exceeds 180. And the latitude never exceeds 90. So if you've got numbers in the hundreds of thousands, you know it's not longitude and latitude. It's probably something like U.S. state plane, which since it measures generally in feet or meters from an origin point, will get up into the high numbers fairly quickly. We'll talk more about this next month when we actually represent some dots on the map. But you can see the results here. For instance, if I go here and try to add my crashes to the map, and I go to display where the crashes occurred, and I use the fields here, but I assume that it's using the same coordinate system as my existing data, what's called my data frame, it's going to give me an error message, or it didn't give me the error, but it doesn't display the crashes anywhere on the map. If I go to them, well, here they are, but where the heck is the rest of the map, right? And it turns out that the rest of my map and where the crashes are absolutely nowhere near each other. This is a very common thing to happen when you go to map your crime or crashes and you don't know, or you choose the wrong coordinate system. So if I know what kind of coordinate system that I'm using, and I tell ArcGIS this fact, and again, I'll walk you through this whole dialog box more later. This is just for emphasize the importance right now. And ArcGIS, of course, has to go and make a fool out of me, even though I chose the right coordinate system. Oh, no, it put them on there. I'm sorry. And now we've got the crashes on the map. So these coordinate systems and projection issues, even though they're complicated, can be important. The good news is that when it comes to your source data, your streets, your water, your buildings, whatever you get from online sources or from your own GIS department, as long as it comes with a projection file, ArcGIS will figure out how to combine multiple projections in the same map. You don't need to worry about that at all. It's only when you have data that ArcGIS doesn't know what the projection is that you have to worry about the coordinate systems. All right, to introduce you to how ArcGIS works, I'm going to start over with a clean map here, and we're going to add data to it. Again, from the city of Allen. Okay, so when you first fire up ArcMap, before you've added any data at all, this is what you've got. You've just got a blank map, and there's no coordinates, no projection, nothing at all in front of you. And so we want to add data to this map from a variety of different sources. And there's a couple of ways. There's always multiple ways to do something in any Windows application. Some people like to use the Add Data button here at the top of the toolbar. And others like to do what I do, which is go and expand the catalog window and add it directly here from the catalog window. Now, if in your own version of ArcGIS you don't see this catalog window, because I don't think it appears by default, you turn it on by clicking the catalog button here in the toolbar, which looks like a little file cabinet, basically. And once I click that and I get my catalog window, I can click this little pin here to ensure that when I'm not using it, it auto hides over here in the right-hand taskbar. So then I just need to click on it again to bring it back. And you can do that with a couple of different windows that ArcGIS uses. All right, so let me just throw one layer on the map here. I'm going to drag in roads. I'll remove that in a bit, but so here's the roads in the city of Allen, just so we have this in front of us. All right. So over here on the left-hand side, we have what's called the table of contents. The table of contents lists the different layers that we've added to the map and the order in which they appear, and then shows us the symbology that the layer is using. And in this case, it shows a fairly random color and thickness for the lines on the roads that I added. So I might want to change that later, but it's showing me what the symbology is here. Over here at the top, you have our toolbars, and I'm showing them, I think, the main toolbar and the, I can't remember what that's called actually, but it's under Customize. We can see which toolbars we're using. So I've got the standard toolbar and the tools toolbar, and those are the default toolbars. There's lots and lots of others, as you see, and you know, we're not going to have time to get into anywhere near the possibilities of all of the different tools in ArcGIS, unfortunately. But this has most of the tools that we need to do our basic mapping and analysis. Obviously, right here in the middle is the map itself. Down here in the left-hand side are some various tools that we can use to change from what's called data view to layout view. Layout view is used for creating a map that we're actually going to print. And so sometimes a lot of analysts like to do all of their work in layout view so they can see what the final map is going to look like. But if we're not creating a map specifically to print out, we don't need to worry about being here. And then there's this refresh button, which is going to come in really handy lots of times, as we're going to see. And so you want to get used to either clicking on that or hitting the F5 key, which does the same thing. And there's a tool here that pauses the drawing of layers in case you add something that seems to be taking forever to draw, and you don't want to wait for it. You can hit that or hit F9, and that will pause the layers from drawing. We'll come back to more of those in a bit. In the lower right-hand corner, you can see in the status bar, it tells us where our coordinates. So it's telling us the coordinates in decimal degrees, which is standard longitude and latitude. And as I hover over the map, I somehow got my layout toolbar, I don't want that. As I hover over the map, it changes where those coordinates to show where my cursor is at any given time. All right, let me remove these roads and start over again when it comes to the process of adding data to the map. The first thing that we have to do when we add data is establish what's called a folder connection. ArcGIS doesn't simply use the standard Windows directories by default. It instead wants you to establish a connection directly to the folder where your data is stored. So for instance, when I click on Add Data, it's showing me basically the folder connections that I've already established, but it doesn't show me my entire Windows directory. I can't see the C drive or my other drives here unless I establish a connection to them. And it's the same thing in the catalog window over here. They both draw from the same source. So I've got my folder connections, but again, I don't get the whole C drive here. I only get the folders that I've established connections too. So if I want to establish a connection to a new folder, I have to do it by clicking on this Connect to Folder button. Again, it's either here in the catalog window, or I can do it here in the Add Data window by clicking Connect to Folder. So let's say I want to establish a connection to my X drive, which has my network GIS data on it. And I'll establish the connection to the X drive, and I don't need all these other folders, so I'm going to establish it to the GIS folders specifically, and then I hit OK. And now it connects to that folder, and notice that it also showed up in my table of contents, and now that's a permanent connection. So every time I create a new map in ArcGIS, every time I open the ArcMap application, that folder connection will be available to me for any new maps that I create. So I'll never have to do that again on this installation of ArcGIS unless I remove it. So I can always remove a folder connection by choosing disconnect folder. Okay, so I've got this folder connection and I've got different folders within it, and here's my Allen data. And what you're seeing here are some of the different data sources that ArcGIS recognizes. If you're like most crime analysts, most of your work with your source data is going to be done with what's called shape files, and they have the extension of .shp. Shape files are an ArcGIS proprietary format that they use for geographic data, what's called vector data. And so, for instance, if I want to add the roads in Allen to the map, I simply need to click and drag. And of course, that's a message I don't have any idea what it's talking about. Let's do it with water to start with. Over to my map. And now I've got my water in the city of Allen. I don't know what that last message was about, but I'll get my roads a different way. Another data source that ArcGIS recognizes is what's called a geodatabase. And this is the type of file that ArcGIS really wants you to make use of. A geodatabase is basically a database that stores your different data files, your different data layers. And so if I expand that, I see a couple ones that I have in my Allen geodatabase. And I'll add streets from that. Allen also recognizes, ArcGIS also recognizes what's called layer files, and I'll come back to those later. They're basically simply shape files or any other file source that also stores the symbology along with it. As you can see, that when I added the data from roads and lakes, it didn't really color them the way that you want your roads and lakes to be colored. So we're going to have to manually change that. Well, if I don't want to have to do that every time, I can make the change once and then store the result in a layer file. So I can just add the layer file from now on, and it has all of my symbology and my labels and everything I'm going to want to use for that layer already set up, and I don't have to do it manually every single time. It also recognizes something called personal geodatabases, which are just access databases, old style access databases using the MDB style. And in this case, I've got some crimes in an access database that I can drag over there, but it won't automatically map them because there's no geography associated with them. The same with this Excel file here. This Excel file has a worksheet in it that has crashes, but if I drag it over, it doesn't automatically represent the crashes because it doesn't know how. The Excel file doesn't have any spatial geography stored with it. It just has coordinates, and so I have to go through an extra step to get the dots on the map based on those coordinates. That's for next month, though. We're just going to work with base map data this month. So what else do I want to add? So I've got water and streets. I'll add the city boundary. And because I care, I don't want it to look like my city is an island, so I want to see what's going on outside my city. So I'll add the roads for Collin County. I don't know, why is it doing that? Just for purposes of getting it to work this time. I'm going to get that from a different source. So I've got my roads from Collin County. And then maybe I want to see some of the other cities and towns that surround the city of Allen. So I'll add my Texas cities layer. Now, watch what happens when I go to add Texas cities. ArcGIS is warning me hey, everything else you've been adding to the map has used the same projection and the same coordinate system, but this last one that you just throw on there, this uses a different coordinate system. And it's giving me kind of a warning about that, saying alignment and accuracy problems might arise, but really it's not a problem at all. It's, again, only a problem if you're doing really finite work, and it really matters whether a line is offset, by a couple hundred feet or something like that. It's basically saying, if I opened this in its correct coordinate system, it would look one way, but because you're adding it to a map that uses a different coordinate system, it's going to look a little bit different. But we won't even notice the difference. So many analysts simply say, don't warn me about this ever again, because ArcGIS does a fine job of combining data from multiple projections on the same map. As we see, the moment I hit close, and now I've got my different cities and towns in Texas. And they don't look wrong to me, okay? And they line up perfectly well with the data specific to Collin County and the data specific to Allen. All right, now this is a good time to illustrate a few features of zooming and moving around our ArcGIS map. Because I zoomed out to see all of the different Texas cities, which you can see sort of form the shape of Texas. Much of what you're going to do in ArcGIS involves zooming in and out and moving around. So here's some of the tools that we're going to use to do that. To zoom in, we have this tool that looks like a magnifying glass with a plus in it. And so if we just click with that tool, it zooms in by a fixed amount, but it isn't very much. More commonly, we're going to click and drag, and then let it go, and it will zoom into the window that we just dragged. If we want to zoom out a little bit, we can use the tool that has the negative symbol in the magnifying glass, and it's a little less intuitive. When we click once, it zooms out a fixed amount, and we can, if we click and drag, what it does is it makes the entire map that you're seeing in the entire map window fit the box that we just created. And so thus zoom out that appropriate amount. Now, if we want to see the entire layer, so let's say we want to zoom in just to the extent of the Collin County streets here, I can right-click on Collin County roads and choose Zoom to Layer, and it will zoom just to the extent of that layer. Okay, I want to zoom into Allen specifically. I can right-click on the Allen city boundary and choose Zoom to Layer, okay, and then it zooms into Allen itself. And if I want to zoom to the extent of all of the layers that I have open, I can use this globe tool here, full extent. I click on that, and now it's showing me all of the open layers, basically the entire state of Texas. And it's very common, when you're doing something to suddenly get lost, like, where the heck did my map go, right? All I have to do is use one of those tools in order to reorient myself back to where I want to be. If I'm transitioning a lot between a zoomed in area and the larger area, I can use these tools here to go back to the previous extent that I was looking at, and then forward again to the last one that I was looking at. All right. Another common tool is pan. It's the hand here, and that allows us to move around without changing the zoom level. Now you're probably saying, well, okay, it's great to see all these features here, but how do I know what I'm looking at? What are these street names? Okay, oh, I didn't add the points back. Let me add those points. Okay. What are these dots that I'm looking at here? Well, we can label those by right-clicking on the layer here and choosing Label Features. We can label them, and so now we see what we're looking at. A lot of churches and a lot of schools in that points layer for Allen here. And of course, I can label streets the same way. So if I right click on the streets layer and choose label features, I now get the names of my streets. Now let's say I wanted to just identify one thing and not everything, instead of labeling everything. There's this tool here for identify. So if I click on identify and then click on a feature like this section of road right here, let's do this one. It brings up a window. So I brought it up on my second monitor and I'm having trouble. There we go. It brings up a window that shows me the features for the thing that I just clicked on. So let me click on the road again here. Okay. So it's telling me that that road is called Sundown Lane. If I click on the city here, it tells me that city is Lucas. If I click on a point, it tells me that point is the River Crest School. And what you're seeing here, when we use the identify tools to click on features and see the underlying data, is you're seeing the record in the database that underlies that GIS feature. And that's really what makes this a geographic information system rather than just a computerized map. Because there's data underneath all of these different physical features. Now, there isn't a lot in the case of the ones that I have right here, but if I got really good data from my own GIS department, for instance, there might be a lot more data underlying what I'm seeing here. And if I want to see the data for an entire layer rather than just one feature at a time, I can right-click on the layer in the table of contents. Let's do cities here, and open the attribute table associated with that layer. And again, that opened up on my second monitor, so I'm going to move it over. I don't want to do that. So here is the attribute data associated with the cities and towns layer for Texas. I've got the city name, whether or not that city is its county seat. There's the FIPS code for the city. It's a national code that's used for a variety of purposes. I've got the population in 1990, 2000, and 2010 within this underlying data layer. And this allows me to do things like select only the cities that have populations of above a particular size. Or if I had crashes for the entire state, I could identify those crashes that occurred within any of these city boundaries that didn't occur in unincorporated county territory, for instance. This is what makes it a real GIS, this underlying attribute data that we can do different analyses with because we have all of this additional information, this additional data. All right. Now, right now, the map is a bit of a mess, obviously. We've got a few things wrong. First of all, none of the symbology is what I want it to be. I've got, and I'm colorblind, so I apologize if I get any of this wrong, but I've got blue roads, it looks like to me, and I've got gray water, and it didn't really draw things optimally. So my Texas cities are on top of my water and my Allen City boundary, so I can't really see my Allen City boundary uniquely, and I can't see the water at all because that's beneath both of those things. So I want to fix this in order to make, and of course the labels are just sort of chaotic. There's a few too many of them, especially as I zoom out a bit. There's too much stuff going on here on this map, and so I want to clean it up a little bit in order to make a nice base map, so that later when I bring my crashes and my crime over here, I can map them, and they'll stand out against this base map layer. Before I do, I skipped something I intended to talk about, and I apologize. But where does all this data come from? You might be wondering. Where do I get the roads and the streets and where do I get the city boundaries and the water for Allen or for Collin County or for the entire state of Texas or anywhere else? Well, the literal answer is I got these from the U.S. Census Bureau. The U.S. Census Bureau maintains a fairly comprehensive database of information and physical features for the entire country. As you can imagine, they have to, because in doing the census, they have to make their way around the country. And the files are called Tiger files. So if I Google Tiger, not Tiger Woods, but Tiger and census and maybe download, I'll be taken to their website where I can download a variety of different data sets for the entire country, really. Right? And you got to know a little bit about what you're looking for. There's some documentation here that will help you figure out what files you need and how to navigate to the right directory. However, ideally, I don't need to do that because the Tiger data isn't great. It's good enough for their purposes. But usually, a good city or county will invest some resources in creating more spatially accurate GIS files for that city or county, and they'll have things that the U.S. Census Bureau doesn't, maybe like building footprints or parcel data or address points or something like that. And so what you really want to do at your level is get together with who maintains the GIS data for your city or county. And I guarantee you there is somebody that does that, because GIS is used in every facet of municipal and county government. It's used for tax assessing, for surveying, for utility planning, for watershed management, emergency services. It's used everywhere. And so there's somebody who's going to be designated as the GIS person, or in a larger city, the whole GIS department for your city or county. And you just got to find out who that is and ask them to give you the data layers that you can use for a good base map. In a small jurisdiction, if you're from a fairly small town or a small unincorporated county, maybe it's a contract person who does GIS for your city or county. But I can't imagine there isn't somebody who does it. So you just need to find that person and get their files, and almost certainly they're going to be in ArcGIS format. All right, so let's make some changes here. First of all, the symbology. There's a couple of things I can do, ways I can change the symbology of what I'm seeing here. I can do it right here in the table of contents by clicking on the symbol that bothers me. So maybe for Collin County roads, I click on that symbol. It brings up this symbol dialog box, and I want to make it I like to make my streets kind of a gray, so they fade into the background and they're not too prominent on the final map. And despite the width ratcheting up and down in increments of 1, or I can actually make a decimal here if I type it in. So maybe I only want the width to be 0.4. That's going to create a nice thin light gray line that's going to kind of fade into the background and won't overwhelm the rest of the map. Already it looks better, right? Okay. But maybe I want my streets for the city of Allen, which I'll put on top, to stand out a little bit more than the ones for the rest of the county. So I'll make it a little bit darker, maybe a little bit wider or something like that. I won't make it much so, just very subtle. Okay. Now that's one way you can do it. The other way you can change the symbology is by double-clicking on the name of the layer and going into the Properties dialog box, okay, for that layer. And there's all kinds of stuff here in the Properties dialog box that we can use to make the map look nicer and to change a little bit about what we're seeing. Now, right now, I'll just focus on the symbology, but we'll come back to some of these other options in a bit. So under the Symbology tab, I can then change the symbol here. There are times that I might want to show a different symbol for different features, not with Texas cities, but later when I get crime on the map, for instance, I might want to show a different symbol for burglaries and for the robberies, or a different symbol for injury crashes, for non-injury crashes. And so that's all possible here with the different options over here on the left-hand side. Again, with Texas cities, none of these really make a lot of sense. I mean, I could do a color ramp based on the population or something, so that cities with a greater population are darker than the ones with a lesser population. But I don't want to do that in this case. So I'm just going to choose the same feature for every city, and that feature is going to be, I don't want any background for my Texas cities. I don't want any background. I just want an outline so I can see where they are. And again, I apologize for my color blindness. I tend to choose bad colors that other people cringe at. But I just want to basically see where the boundaries are, but I don't need to see a background color. For Alan specifically, though, yeah, I'll set a background color, but I don't want it to be this, whatever this is. This is too dark, so I'll make it something more like that, maybe. I hope that's not too bright and garish, and I'll pick a thicker outline so I can see exactly where it is. And of course, that should be on top of the rest of the cities, not below it. Okay. And then for water, of course, I'm going to pick a blue with no outline. I don't want a border around my water. And that needs to be on top of the Allen City boundary. All right, so now I can see where my little lakes and waterways are here in the city of Allen. Okay, so things are looking a lot better, aren't they? And before I forget, because I have forgotten and I need to make sure I don't forget any longer, I'm going to go ahead and save this this map, and I'll save it to my GIS Allen folder here as Allen base map. Now I'm going to come back to this later and tell you more about what saving this does and what the word base map means. But if I forget, if I don't save it now, inevitably something's going to cause ArcGIS to crash, and I'll have to do this all over again. So
we just had a question, Christopher, about that very thing. Oh. Demetrius asked, "What about using the Add Base Map feature?"
Yes, I will come back to that. Thank you, Demetrius. Yes, there's a way that we can add an online base map if we don't like or we don't have the data to make up a base map of our own, and I'll come to that in just a bit. So good question. Another thing I might want to do here is rename some of my layers. They're actually not named anything terribly offensive right now, but occasionally you'll get data that instead of something like Collin County Roads is labeled TX00485 RDS.SHP or something like that. And in your table of contents, that's really not very easy to work with. So without renaming the original file that it came from, I can rename the way that it appears here on the map by going into the properties and then the general tab. And the only thing I'll do here is put a space in between Collin County and Roads. I wouldn't want to put spaces in my file name, but I certainly want to put spaces in it the way it appears here on this map. And that way later on, if I go to print this and I make a legend, this is the way it'll appear in the legend instead of with all of the words smushed together, which tends to look a little bit amateurish. Okay. And the same thing with city boundary. Now, I don't like right now all these labels on here. I mean, I want to see labels, but I don't want to see them all the time, especially when I'm zoomed out to this layer, to this level rather. And so there's a couple of things we can do with labels. First of all, if I double click on streets and go into the labeling, or the labels tab here. Okay. I can do a lot here. I can tell it what to use for the label. Fortunately, it figured that out already. It's using the full name field for the street layer. So if it had used something weird like the object ID when I originally set the label and put a bunch of numbers all over my map, I would have had to go here and tell it, no, that's not the field that I want to use. And I can set the font and the color and the style that I want it to use. I don't want it to be black. That tends to be a bit too stark. And when I get my dots in the map here, that's going to make it hard to see the dots. So, again, I'll make it a gray and have it fade into the background a bit. And that makes it a little bit nicer, see? But it's still a bit too many labels. So actually, I'm going to zoom in first. So let me zoom into this box here. And I'm going to go here to my labels and tell it that I don't want to even see the labels for the streets under scale range. I don't even want to see them unless I'm zoomed into the current zoom scale that I'm zoomed into now. So when I'm zoomed in here, I can see my labels, but when I zoom out, oh, too far. When I zoom out to the entire city, my labels disappear. And the same, maybe the same thing for these points, but actually when it comes to the points, I don't even want to see the points for the churches and the schools unless I'm zoomed into a certain level. Maybe let's say this level here. All right, and so I'm going to go into my properties for my points layer, and I'm going to go over here to my general tab, and I'm going to tell it, don't even show this entire layer if I'm zoomed out beyond where I'm zoomed now. And so that way, when I go back to my entire city of Allen, I don't see a bunch of labels, I don't see a bunch of text, I don't see a bunch of points on the map. It's only when I zoom in to a certain level that I start to see those features. And you can really do some cool stuff with that. When you have much more detailed shape files, maybe parcels, for instance, you don't want to see them until you zoom into a certain level, or building footprints. My Texas cities, I don't need to see them when I'm zoomed in, so I could set them to disappear when I zoom into a certain level. So at this point, I've got a reasonably good base map. I could have a better one if I, again, was working directly with the city GIS department to get more spatially accurate labels, but this is pretty good. This is going to allow me to get my dots for crime, for crashes on the map here, and they'll stand out against the slightly subtle background. Notice there's nothing dark, there's nothing black, there's nothing bold, and so when I put my dots on the map, let's go ahead and do that, even though it's next month. We'll talk about how this is done and what all this means. Just as an example. So now I've got my crashes in the map, and I can symbolize those to be a little bit bigger. And now they stand out against the more subtle background that I've established for the streets and the other physical features. Okay. Now, without the crashes, I'm going to save this as a base map. I'm not going to remove the crashes, but yeah, I'll remove them. All right. So I remove the crashes. I've got things the way I want. I've got the symbology the way I want. I've got the labels the way I want. I've got everything exactly the way I want. And I'm going to use this map from now on as the base, as the starting point for any other map that I create. And so that's why I go and choose File and Save this as my base map. Now, it's important to understand when I save a base map, which ArcGIS uses the extension MXD. When I save it, I am only saving basically a pointer to all of the different data sources that I use to create the map, and then the symbology and other properties that I've established here. I am not saving the data itself, and so if I delete or move any of the source data files, when I go to open the map, it's not going to be able to do it. It's going to give me an error message because it still needs to have all those sources in the same place that I got them from. All right, so you're not saving your points, you're not saving the water, you're not saving the streets. Those are all where you originally got them from. You're only saving the way you symbolize them here, and you're saving the link to them, basically, that you've established. So the MXD document, you can't like copy that to a flash drive and then take it to a different computer and expect to open it up and get the same map. It doesn't work that way. You have to have all of the source data in the same place in order for that to work. Now, getting back to the question, what about the online base maps that ArcGIS comes with? Let's say you didn't have any of this source data, and yet you still had a need to represent your dots in the map. Let me start over with a complete blank map here. And so in this case, I've got Allen, I've got some crashes for the city of Allen. And there they are, but I don't have any base map data, and it's going to take me a while to find it, or something. The GIS director for the city is a jerk, or whatever the issue is. You still want to try to get it if you can, but there are some online options that ArcGIS offers. And so here under Add Data, if I click on the little drop down, the little arrow next to it, not the plus, but the little arrow, I get an option for add base map. And when I choose that, ArcGIS gives me a number of options for different online maps that can basically serve as a base map for some purposes. And the standard one is streets here. So if I choose that, I have to wait a little bit because it's doing an online connection to a fairly large data source. So this isn't going to work for you if you're not connected to the internet when you want to use this, right? But there it is. So I've got a decent base map underneath Alan, and as I zoom in, notice that they've implemented for this base map some of the same things that we implemented just a minute ago. Certain features don't show up until you've zoomed in to a certain level, like these different building footprints here. And then as I zoom in even further, some of them get labeled. Now, there's good data here. Obviously, stuff I don't have, like the the names of businesses and the footprints of businesses and so on. So a lot of analysts like to maybe use these exclusively. Again, they have the negative of you have to be connected to the internet, and it takes a little bit of time for it to refresh sometime. But because the base map isn't separated into different physical features, I can't choose my own symbology. And if I think that maybe it's a little bit too stark, it stands out just a little bit too much, I can't make it like fade subtly into the background or anything. I can't change any of the symbology for the base map features. I can't separate the base map features, and so I lose a little bit of functionality. And I also can't do some things that you might want to do later on with your own base map data. For instance, this points file has schools in them, and I might want to say map, if I had crimes here, I might want to map all of the crimes that occur with a certain perimeter, a radius of those schools. Well, I can't do that if I don't have the schools as a separate file. And so the base map data, even though it labels certain schools, doesn't give me the ability to do any kind of automatic selection of those crimes that occur within a certain radius of those schools. So the base maps that you can get online, even though they do look nice, they do lack some utility of having your own base map, and it's best to use each for its own strengths. Incidentally, I find another base map that's often very useful is the one titled Light Gray Canvas. It's much more subtle than the other one.
And we have another question, Christopher.
Okay.
Because the world street map is so large, can you select the area you want to load?
Yeah, I'm not aware of any way to do that. So it's a good question. I shouldn't say definitively no, but I'm not aware. I think it actually does kind of prioritize the area that you're in, and then if you zoom out even further, it loads the rest of the data. But I don't think you can manually select the area or save for offline purposes just the area that you care about. Notice how this how nice and again, I'm sorry to keep using this word, subtle, the background is for this light gray canvas. It's a really good one if you're trying to map something and you want some basic geographic information in the background, but you don't want to see the features so starkly. Oddly enough, notice my crash has disappeared as I zoomed in, and this occasionally happens to me when I'm using online base maps, where sometimes the features from my own map disappear, and I've got to remove the base map in order to get my crashes to come back again. So there are little quirks like that sometimes with ArcGIS that you just got to push through. Okay, so the last thing that I'm just looking over my notes here to make sure I covered what I wanted to cover. The last major thing I want to cover before we wrap up this webinar is the different types of files that ArcGIS is using in more details, because it's important that you understand this. So over here, I've got the different files that we've used in order to create our base map. Let me actually go back to the base map. It's important you understand how these different files are stored. Oh, I'm sorry. I see something I totally forgot to talk about. I apologize. All of these different the layers that we've added to the map are stored in something called a data frame. And the data frame is what's up at the top here in the table of contents, titled layers. I can title it something else if I want. The data frame has its own properties associated with it, as you can see from this properties dialog. So I could title it Alan, for instance. And there it is. Notice that the data frame also has a coordinate system associated with it. And what it does is it automatically adopts the coordinate system from the first layer that you added to it. So I think in my case it was water was the first one that I added. So whatever the coordinate system that the water file uses, that's what the whole data frame used. And I can change that here if I want. If I want the data frame to use a different coordinate system, I could do that here. So you could have obviously multiple maps going with different data frames. So if I wanted to, in the same project, in the same overall map, I wanted to add, maybe a different city or the entire state of Texas or something like that, right? I can choose to insert a new data frame, and maybe I'll call this one Texas. And then I can drag in data from, say, the entire state of Texas. I know I already had that layer, but you get the idea. All right, and I can switch between them by simply right-clicking on the data frame and choosing Activate. And that will switch me between the two. Later on, when I go to make a map maybe for printing, I will have an option to have a different window for each data frame that's active so that I can combine them together, maybe do an inset for one and a larger map for the other or something like that. Again, that's something we'll cover more in detail later, but that's how you get multiple different maps of different geography in the same mapping project. You just insert different data frames. Okay, I was talking about the way this data was managed. So when I go over here to the catalog window and I choose to add data from this Allen directory, I see all these different shape files. But what we're seeing here is actually only one file of many that make up this data layer. And we can see the actual files if we go and open the data in Windows Explorer rather than the ArcGIS catalog. So this data here is, for instance, called Allen Water. Even though when I go to ArcGIS, I only see the shapefile called allenwater.shp, when I'm in my Windows directory, I can see that the Allen Water layer is made up of all of these different files with different extensions, CPG, DBF, PRJ, SBN, SBX, etc. And all of those together make up the data layer that we're seeing on the map, even though ArcGIS only shows us this SHP file. So if I was copying this layer to another directory or thumb drive or something, and I wanted it to be available to, or sharing it with another analyst or whatever, I would have to share all of these files, not just the SHP file. And they all do different things. SHP stores the actual vector data to represent it spatially on the map. DBF is the underlying database that goes along with it. PRJ is the projection. SBN and SBX, I think, are index to make it easier to do searches. CPG is the encoding that the file uses. I think it's actually a new extension that only started coming with, I think, ArcGIS 10.4. Some of them aren't technically necessary, but you generally want to get in the habit of, if you're copying the data, to copy the entire set of files that go along with the shapefile that you want to copy. This also means that if I want to rename this, if I want to move it, if I want to delete it, I can't just delete the shapefile or rename the shapefile. If I rename Allen Water to, Allen H2O or something, but I don't rename the rest of them, it's not going to know how they work together, and it's going to cause problems, which is why for moving, renaming, deleting files, you almost always want to use ArcCatalog instead. So that ArcCatalog only shows us the shapefile. It only shows us the .shp version of the file, but trust me, it's all there, right? And so if I'm not sure it's going to let me do it whether it's active. I can't remember if it does or not, but let me try. So if I rename this, Allen PTS. Yeah, it won't do it while the file is active in a here's one I don't it's not active. Okay, so I'll rename Allen address as Allen ADDR or something like that. So I've renamed the shapefile here in ArcCatalog, but ArcCatalog is smart enough that back in Windows Explorer, it's renamed all of the associated files to ADDR. Right. So do your moving, renaming, deleting in ArcCatalog, not in Windows Explorer, and you'll be much happier and less likely to break the link to your files. Again, the base map, which I've saved here, is pointing to all of these other files here. So if in between the times that I use ArcGIS, I delete any of the files that the base map uses or rename them or move them, when I go to open the base map, it's going to give me an error message and it's not going to be able to find them, and I'll have to make the base map over again. So you've just got to be cognizant of that. And for those more advanced users, I just want to point out that an awful lot of these files can simply be opened in Notepad if you want to start to see a little bit about what's in them. For instance, let's say you have a base map file, but it's you get errors opening it and it's just a bunch of chaos. Well, I can open the base map in, I'm sorry, I just hit open, so it's going to open in ArcGIS. I just open with, and I can open that base map file in Notepad. And although it's a little bit tough to understand what this is saying and the encoding isn't right, if I can scan through here and figure out basically what files the base map wants and what projection that it's in, and occasionally you can use that to repair a base map that goes awry. But generally, if you start getting those errors when you open your base map, you've just basically got to start over. Okay. All right, next month. Now that we have our base map and we know how to maneuver around our ArcGIS window, we are going to get into the process of then putting our crime data and our crash data onto this map. And that's going to involve a lot of process. Sometimes it's really easy, like it's been with the crash data that I'm working with here that I got from the Texas Department of Transportation because it already has its coordinates in it. And so all I have to do is tell it to show me a dot at the intersection of those two coordinates. And it's nice when you have data that has coordinates in it, because that really is all you have to do. But occasionally you get data that doesn't have coordinates, it just has addresses. And then you've got to get ArcGIS to assign the coordinates to the data based on a process called address matching, which matches the addresses in the file that you have against the physical features on the map and tries to put the point in the right location. And that's a little bit more annoying and harder, but a lot of analysts have to do it. So we're going to go through it in detail next month. For now, let's just take a look at our objectives. So today we took a look at the definition and uses of GIS for DDACTS, what DDACTS was, how to move around the map, and the different data sources that ArcGIS understands so that we can get them on the map, and how to symbolize those different data sources in order to create a base map for further mapping. At this time, I will be happy to take any other questions. Oh, my apologies. Do we have any more, Mark?
All right. Demetrius had that question that was already answered, and we'll give people a chance to.
While you're thinking about any questions you might want to ask, I'm going to put up my contact information here and the contact information of the Texas DDACTS project manager, Dan Howard. And my understanding, Mark, is if people want a recording of this webinar to view afterwards, they're going to want to contact Dan. Is that right?
That's correct.
Okay, and they're going to get an email with
a link back to a Dropbox file.
Okay, very good. Okay. No, but is everybody going to get an email with his contact info, or should they write it down now from here?
Actually, I was going to, in fact, I'll go ahead and send that to them right now. Everybody go over and take a look at your chat box, and you should see the contact information for Dan Howard and a number of other information. Demetrius also asked, will we receive a sample file for map points on the next webinar?
Yes, for the next webinar for crime and crashes, I'll have a sample file for you. So if you want to follow along with the samples that I'm using, you're able to do it. But if you have your own data, of course, it's much more meaningful to work with your own data if you can.
All right. Do we have any other questions, folks? All right. Once again, if you go over and take a look at your chat log, I just sent you the information about how to contact Dan Howard, and so you can cut and paste that.
All right. Well, having seen a GIS in action, I hope you understand why it's more important than just a computerized map, and why police agencies and their analysts really need this technology to properly address crash and crime hotspots. So please rewatch the recording of this webinar and use the associated resources to create and navigate a GIS-based map for your own agencies in preparation for the next webinar. And that's where we'll learn exactly how to take our crime data from our records management system and our crash data from our crash system and start representing it on the map and analyzing hotspots. Thank you very much for your time and attention this afternoon, or this morning.
Yeah. All right, folks. So once again, as is typically the case, the opinions contained in the program that we just heard are those of the creators and don't necessarily reflect the official position of TxDOT. I already sent you a little bit of information about how to access Dan Howard, how to access Peggy Schaefer, the national DDACTS coordinator, if you're watching this from out of the state of Texas. A good resource for anybody that is involved in law enforcement training is the National Law Enforcement Academy Resource Network, NLearn, which is a free resource from my analyst. And you can learn more about that by going to www.nlearn.org. This is the second set of webinars in the series. We have the 5-part Microsoft Access series. Those recordings are available again through Dan Howard. This 3-part webinar series that we're doing right now, and portions 2 and 3 to come in the near future. And then it's going to end up with a 2-day in-person hands-on class in San Antonio on June 21st and 22nd. And our analyst is going to be able to pay the lodging and per diem for the Texas students. Again, the webinars that have been going on right now, I'm going to give you some information about how to register for the other ones here. If you go over and take a look at your chat box right now, I'm going to go ahead and send that to you as we speak. And so that should show up in your chat box right now, how to access dots on the map on February 8th, and also identifying and analyzing crash and crime hotspots on February 27th. And that should be on your screen right now in the chat box. All right, once again, as is typical, we always want to find out how we're doing with these. Tomorrow, when you're going to receive a follow-up email from me that asks you to take a short survey. The survey link is right here. If you don't want to wait till tomorrow, I will go ahead and give that to you right now. I'll copy that and send that now also to you through the chat box. So please take the time to complete the survey. It's only a few questions, and it really does help us out as we go through this and tell us what we are doing well and what we can improve on. And then lastly, this is what you've all been waiting for. This is how you take the test for this webinar. You go to the first forward site, and I'm going to, again, copy this and give this to you now on the chat box. So everybody take the time to right now go to that chat box and cut and paste this. Go to the first forward site with that web address, and your test code for this particular class is called location, all smalls. You need to pass this with a score of at least 70%, and you have 24 hours from this point in order to take the test. You can't take it, and it'll lock down itself after 24 hours, so make sure you take it within that amount of time. This course is certified through the IADLEST National Certification Program, and so for those of you in Texas, it is applicable towards your in-service training credit that you need to have every year through TCOL. And this is certified as it is in 34 other states around the country. Check your state if you're not in Texas to see whether it is NCP certified classes are appropriate for your state. They are in most states in the country. Other than that, I want to thank you for your time and your attention. Be back with us on February 8th for the next in our series. And unless there are any further questions, thank you, Christopher, for your time, and we'll see you next time.
Thank you all.